A very good afternoon to all of you. I, Akriti Kumari, on behalf of CII, would like to welcome everyone to the CII series of webinars on Industry 4.0 for India. The topic for today's session is Industry 4.0 in Action, Harnessing the Power of Data for Improving Shop Floor Productivity and Profits. The session is brought to you by our partner, AceManufacturing Group. I would like to welcome our esteemed panelists for today's session. Mr. K Ramesh, Managing Director, Micromatic Machine Tools. Mr. Ramesh is the Managing Director of Micromatic Machines Tools Private Limited, the company, marketing company of 2,500 crores. He has done his Bachelor of Engineering in Mechanical from BMS College of Engineering in Bangalore and first class distinction postgraduate diploma in Business Administration from Bangalore University. He has an experience of 38 plus years in marketing and management of capital equipment marketing, machine tools, CNC lathes, machining center, cylindrical grinders in domestic and international markets. The second speaker for today's session is Mr. Madhu Kestur, Director, AceManufacturing Intelligence and Tools. Mr. Kestur is an engineer by background with a BE in Mechanical Engineering and an MTech in Computer Engineering from NITK, Suratkal. He has 30 years of experience, is responsible for product engineering and delivery of all AceMicromatic products. With his rich global experience at large MNCs, he brings a global perspective to innovation and product engineering. A very warm welcome to all the participants joining today. Before we begin with the session, I would request the participants to post their questions in the Q&A sections. The questions will be taken up by our panelists one by one at the end. I would also request our panelists to kindly keep themselves on mute when they are not speaking. So without further ado, let's begin with today's session. I would request Mr. Ramesh to kindly begin the session. Over to you, please, sir.
Thank you, Akriti. Thank you very much. Madhu, can you please share the presentation on the screen, please?
Yeah, just a second.
Good afternoon, ladies and gentlemen. It gives me great pleasure to welcome each and every one of you to this afternoon's presentation on the IoT Industry 4.0 solutions that the AceMicromatic Group could offer. I'd perhaps spend the next 5 to 7 minutes with you where I will take you all through very briefly an overview of the group and Amit, which is our technology principle that brings out the IoT solutions. The AceMicromatic Group very strongly believes in serving customers, hand-holding them, and put manufacturing through the SME and the MSME sector on the global map. As many of us here are aware, for a country to be competitive and productive, it definitely needs the big branded players in product manufacturing, but it's the supply chain that really makes the big branded manufacturing companies a success. So with this background, I'll take you through us. Next slide, Madhu. We are known as the AceMicromatic Group. We are in the machine tool space. We make machines that are in the turning, milling, grinding, productivity equipment. These are the products that we make, and making machines that can make other machines or other parts. Some time back, we got very involved and interested in not only giving our customers good machines, but also giving them a methodology by which they could monitor these machines and understand how well these machines are functioning. We have a turnover of about 30 billion rupees, which is close to about 425 million US dollars. We've got 13 plants in Bangalore, Ghaziabad, and close at Dobispet, close to Tumkur. Our team is about a little over 3,000 people, and over the years, we've got more than 50,000 machines working in the field. If I'm not mistaken, at this point in time, we're about 56,000 machines. For those of you who have heard and who know, ACE Designers is our turning machine manufacturing. AMS, which is ACE Manufacturing Systems, are our machining center manufacturing unit, and Micromatic grinding is our cylindrical and centerless grinding machines. Like that, Amit, which is AceMicromatic Manufacturing Intelligence Technologies, acronymized as Amit, was the company which is one of our youngest companies. When I say young, what I mean is sometime in the early 2000s, was set up to bring in IT, digital systems, measurement systems, and productivity and production systems to the shop floor so that they could be used to look at what actually happens in the shop floor and connect what's happening in the shop floor with the planning floors, or what we would call the top floors. And this was the purpose of setting up of Amit. Like I mentioned, we started in the early 2000s, and the first few years, the 2 or 3 years, was thinking about these solutions, developing software and also the necessary hardware that could be connected to machines, whether they were CNC machines, whether they were even non-CNC legacy machines, so that from these machines we could get digital output either directly from the machines or through some intermediaries that were working on these machines. We have, I believe, close to about 20,000 installations in India. We have also supplied some of our solutions in Europe, Thailand, and along with our machines and many of our customers in China. Like I mentioned, 2002 to 2005, the initial days, because we come from a hardcore manufacturing and machine building background, our solutions, the software and hardware, have actually been tried, tested in our own shops, in our own vendors, so they are extremely robust. And this was at a time when Industry 4.0 was not even invented as a terminology, and we did not even hear of what IIoT was. At that point in time, we used to call them production monitoring systems or solutions, which got converted into productivity monitoring solutions, because that's what we were trying to look at and trying to measure. And we've got a lot of kudos and a lot of support, and we've been awarded many times for what we did at that point in time. Very quickly, a picture of one of our earliest days. This is a picture that was at the Intech exhibition in Coimbatore. The year, as you can see, is 2005, when the then President of India, Mr. Dr. Abdul Kalam, was at the show as the chief guest, and he spent a lot of time in our booth, enamored by the solution and saying that here is somebody who's trying to do something which is of digital nature in the hardcore production and shop floor fields. Like I mentioned, credible associations, credible publications like the CMTI, IMTMA Siemens, and FIE Foundation awarded us right in our inception early days of 2006, 7, 8, and 9. And there has been a series of awards, not only from such august industry bodies and associations, but also from many of our customers with whom we have partnered to give them solutions that help them grow their business. As you could see, we were adjudged the best business partner by Triveni in the year 2017. The Economic Times looked at our work and spoke to our customers and recognized us for brand being the best brand in smart manufacturing in 2018 and 19, and ET Rise 2020 also awarded us and recognized us as the best MSME brand. Like I mentioned, we come from a manufacturing domain. We have machines that are working across various industry segments: automotive, aerospace, railways, defense, the infrastructure industry such as construction, general engineering, and of course, training and education. So what that gives us is all our solutions are tested and tried across a variety of industries, and the best practice across all these segments have been thought about and are a part of the solution, so that you have a product that is ready with best practices and that could be used. Coming very quickly to why are we here today and what is it that we are trying to do. From an Indian context, if we look at just the last 2-3 years, 2017 onwards, and where we are trying to head to, say 2025 or even 2022, we could see that manufacturing has to grow to become a significant part and a contributor to our GDP. The population here, we were around 1.3 billion people, and we're expected to be close to 1.5 billion people by 2025. And this means that demographically, we will be having a huge set of people who need to be productively in the workforce, which could be around 100 million people. And the government of India, and if you look at it from a global perspective, we are heading close to become a 5 trillion economy from the close to 2,500 trillion economy that we were a couple of years ago. So if this is happening, what really we need to do is, one, put manufacturing as a big contributor to GDP. And if manufacturing has to contribute, we really need to look at developing the human capital and convert them into good, sustainable, productive resources. And one important aspect that needs to come into play is a lot of information, a lot of digitization in the manufacturing space, that is looking at our shop floors from a different perspective and extracting information that is lying in the different parts of our shop floor into our decision making. We have been seeing, especially in the post-COVID scenario, that there are a lot of opportunities coming into India, and everybody now is talking of, specifically from a manufacturing perspective, as the China Plus One initiative. And there are many countries that are competing to be that China Plus One. And of course, India is one of the probable countries that are waiting in the wings. While this is an extremely good thing to happen, global opportunities automatically means that there's also going to be global competition. And when it comes to competition, whether it is quality from a time perspective, quality from a dimension perspective, quality from a surface finish perspective, and quality from a reduction of waste perspective, has to be not at all there or should be tending towards zero. Last but not the least, an extremely important issue is about traceability. While be it cars, I don't even want to talk about aerospace or aeroplanes, because traceability there is absolutely critical. But coming down to cost and cost of quality, traceability is going to become a very significant and an important part in the manufacturing, where small parts and sub-assemblies that go into a making of a big product need to be traced, tracked, and histories maintained. Now, if this has to happen, I cannot even think or imagine of any other way of doing this other than a digital way. So there's going to be a huge requirement of digitization, customization, and all of this is going to be made in small batches. Like all of us can see, if the automotive industry is growing, it's growing because we are bringing in more and more models. And big batches are being broken up into smaller models with incremental innovation that is happening on each and every point, at every release of a product. So this means quick turnaround times. This means tracking across several small batches. It also means customization. And when all of this increases, the data that's going to be associated with all of this is also going to increase. So if we really need to be productive, and if we need to be consistent on our delivery and also keep our costs low, we must look at getting it right the first time. And to keep getting it right at the first time, we must be working with actual data in real time. So this is why Industry 4.0, from a manufacturing perspective, is extremely important and needs to be looked at very, very carefully. I will be very, very quick on this. From making money, ultimately, which is the bottom line of industry, this comes from increasing effectiveness, which is efficiency and utilization, reducing cost for every component that is made. Third, the people who are making these components need to do it with a sense of empowerment, and empowerment comes from data. The machines that are running need to be maintained, and if they need to be maintained, then we need to move from breakdown maintenance to preventive maintenance. If we do all of this, we really look at eliminating waste and making more money, and this never ends. So the virtuous cycle, for it to keep going, we need to continuously be looking at more information, which is MIS and audit. Very, very quickly, if we look at a machine, that a CNC lathe or a machining center, the average machine hour rate on a machine that's about 20 or 25 lakhs works out to be somewhere in the absolute value of 400. It could be rupees, it could be yen, it could be dollar, depending on who you're making those components for. And assume that by going in for Industry 4.0 solutions, we get a 10% efficiency. We have seen cases, which of course my colleague Mr. Madhu will be taking you through, where we have seen far higher improvements, but even at a base rate of about 10%, we perhaps are looking at increase in machine hour rate of 40 units, which again means at 600 hours per month, we are looking at a revenue of 2,40,000, or an increase in revenue of 24,000 by this 10% increase, which is 10% of 2,40,000. So what I'm really trying to show you in this is 24,000 rupees or $24,000 or 24,000 units per month gives you an annual value of about 2,88,000 units in a year. And typically, an investment to do that on one machine perhaps would be somewhere in the 1 lakh range. So if you're really looking at return on investment, what you mean is you get back in 4 months the 1 lakh, which is again 24,000 rupees into 4, which is going to be the investment that you're going to be making per machine on digitization. So you are looking at close to 3 times the return on your investment. Now, with these words, I would like to hand over the presentation and the remaining portion of this to my colleague Madhu, who will take you through the case studies and go into more depth of what I'm talking about. Madhu, can you please take over?
Thank you, TK. Good afternoon, ladies and gentlemen. I will continue from where Mr. TK has left. When we work with customers, we always look at defining productivity. What is productivity? So productivity can mean different things to different people. Let us say for a high quality part manufacturer, quality itself becomes productivity. So let us say in our own group, we have examples where a Marcel makes aerospace components where the batch sizes are like 10 numbers or 15 numbers. And the materials are exotic. So if the operator makes a mistake and one part is lost, the entire margin on the batch is lost. So for high precision quality manufacturers, high precision component manufacturers, quality becomes a measure of productivity. Similarly, somebody in the high volume game, like an automotive parts manufacturer, the assets or the machine should be up and running all the time. So asset utilization becomes a measure of productivity. Somebody like a Maruti, suppose he has made 98% of the car and the last 3-4 items are missing, he cannot ship out the car, then the entire productivity is lost. So for product companies, having the right materials at the right time for assembly becomes a measure of its productivity. So on and so forth. Each customer or each segment may have their own perspective on productivity, but when we say improvement in productivity, ultimately it should result in bottom line, increase in profits. So that is what a customer will look for. So we start with baselining the company. Our customers generally, they have passed these two phases of 1 and 2, where computerization has happened and they have connected all the systems. There is some connectivity already established within the company. The digitalization phase is over, and then that is where you start getting into Industry 4 phase. So the first step in Industry 4 is to start getting visibility or seeing into what is happening on the shop floor, and then trying to understand what is happening in the shop floor. So these two stages, 3 and 4, are extremely important for an Industry 4 project, and this is where most of the customers are right now. And stage 5, once you have collected a lot of data, a lot of information, you start being prepared. You start building in predictive capabilities. And this is how an Industry 4 journey goes on. So then you talk of self-optimizing systems, where downstream machines can get some information from the upstream machines and then accordingly adjust the output of the line and things like that. So self-optimizing systems will be work in progress. Right now, most of our customers are in the phases 3, 4, and 5. So any I4 project can be looked at as an intersection of 3 axes. One is you select a process, example production. You would like to optimize production. What is a smart step that you take in that direction? It may be a decentralized decision making, for which you need data. And how would you get that data? You apply a technology component. So an intersection of your process, a smart step in that direction, and the technology component that goes into achieving that objective. This intersection forms the work for the Industry 4 project. In our own experience, we have come across many cases where most of the issues are routine in nature, they are low-hanging, transient in nature, and nothing to do with high-tech engineering. So this is one of the misconceptions that people tend to carry, that a lot of these issues are high-tech in nature. This is not really so. And in our experience, we have seen that only 15% of these issues may be addressed with better field, better speed, better fixturing, etc. But 80% of the productivity increments are low-hanging in nature and can be addressed by monitoring systems, real-time monitoring systems. So we connect machines and shop floor equipment either with hardware or without hardware, and then take the data to a central server where industry standard computations are made, and then analytics, which are very actionable in nature, are provided to the end user in real time. So to talk about the topology, any shop floor will have a variety of equipment. It can be a sensor, it can be a PLC or a CNC, wide variety of data sources. And we need to connect up all these different data sources and take it to a common platform. Then we provide industry standard computations in our analytics engine. And the analytics engine in turn feeds the enterprise systems such as the MES systems, ERP systems, etc. So a two-way communication is also possible between your ERP and MES systems to our analytics engine. So there is an optimization feature in real time which will also feed plugins for real-time alerts, knowledge systems or quality systems to give some feedback back to the shop floor. So you have a data acquisition layer, a data analytics layer, and then a real-time alerting and actions layer. So our solutions have to be agnostic to the manufacturer, application, and protocol. So we work with several protocols like RS-232, RS-485, or OPC UA, Focus, MP Connect, etc. Our solutions are application agnostic, so they work equally well with metal cutting, metal forming, or be it injection molding, any type of application which has got a discrete start and a discrete stop, and outcomes apart, our applications will fit in very easily into those scenarios. And the manufacturers as well. So we not only work only with our not with our own machines, but also we work with Mac machines, Amada machines, Puma machines, and so on. So any shop floor will have a wide variety of entities and control manufacturers. So we have the capability to work with any of these manufacturers, almost all manufacturers that we come across in India. So we advise our customers to start the vertical integration first. What we mean by vertical integration is you start with one department within the organization and then take the data from one department to the other department. So you are basically integrating all the functions in your organization. So you can start with manufacturing and then integrate your purchasing and logistics into this. And then once you're comfortable with the vertical integration, you can start bringing in your suppliers, vendors, customers, etc. So that will be your horizontal value chain. So there is a data acquisition process, analytics process, a feedback process, and an integration process. So these four stages will, the process will be involved in your industry project. So this diagram represents a typical shop floor where you have wide variety of equipment and the touch points that we could imagine. So there are several touch points that we have already covered. Right from the beginning, where the material starts flowing into the factory, we can have Industry 4 systems which will track these materials and allow them to be stored in certain areas. The ERP or MRP runs release the schedules, and this process can be automated through what is known as eShopX solutions. This is our digital recipes for manufacturing. So the operator would come to the machine in the morning and then use a console to look at what needs to be done in that shift. He would select a particular schedule, and all the associated documentation for that schedule to carry out his work will be made available through the console. And then he can, he has no other worries such as am I using the latest version or is there a problem with this program or documentation. So everything is taken care in the background by a planner, and it also brings in a paperless working mechanism into the shop. So as he starts producing, we monitor OE from the machine, which comprises of availability, performance, and quality measurements. So the product of APQ gives the OE of the system, and we monitor it in real time so that any problems that occur in the line or the machine can be alerted in real time to the right people. And the follow-up actions that will be taken on these alerts will definitely keep the OE intact. We also have the ability to integrate quality systems like digital gauges or PMM machines, etc., into our own system, so that there is an online SPC visibility, statistical process control visibility on critical dimensions. And if something is going out of process, again, alerts are codified to reach the right people at the right time. So we also integrate energy monitoring or the energy consumption along with part production for the customers to have an idea of specific energy consumption, or if their power factor is going bad, or if they have a new process in place or a new part in place, how much energy is being consumed to make that part. So the correlation between AC energy consumption and part production can be very useful for the customers, especially in a forging process or a pressing process. We also have systems which help the maintenance department to understand the machine performance better in the form of machine diagnostics. These solutions are available on later controls like one of OITD and above, like focus level, and Siemens A280 above with OPC capability. Or it can be a Mitsubishi control, some other control, etc., where controller supplied API libraries are available. So you can dig deep into the control and generate a lot of useful information for the maintenance person. We also have assembly monitoring systems, and the data that is collected from all these sources are made available in the form of shop floor handoffs, similar to what you see in an airport or a railway station, showing the real-time status of the aeroplanes and the trains. So we show the real-time status of every piece of equipment in the shop floor, so that the operators can themselves see and improve what is going on in the shop. So right all the way up to the material going out of the factory, we can have the traceability system, which will correlate the serial number that is being manufactured with all the process parameters that have happened along the line. This is a sample schematic where we deploy a piece of hardware at the machine, collect the 24-volt DC signals from the machine to monitor OE. In this schematic, we are also showing the integration of energy meter for correlation between part production and energy consumption. So all the data, let us say we have connected 100 machines, all the data goes to a central server where the analytics is run, and the analytics, the outputs of these analytics is available for anybody in the factory or even outside of the factory. So this is a typical supervisor cockpit which shows several machines. Each box represents a machine. It is color coded to attract attention. And whenever you see red on the box, you can drill down to see what is happening. So that actions can be taken. We also have mobile applications to draw attention. It gives you data for today, yesterday, and day before yesterday. So important parameters like part count, downtime, utilize time, availability efficiency, performance efficiency, OE, etc. are made available so that somebody who is not in the shop floor, not in the factory, and traveling between plants, etc., can keep track of what is happening in the shop floor without asking anyone. This is an example of what we call an add-on display in the shop. This is designed to represent the layout of the machine and give key parameters. I mentioned the data capture from digital gauges. Such data also can be projected in the add-on display with clear color coding of to attract attention if some process is going out of control. So we have online HPC dashboards, and we have diagnostic systems where it shows it can show coolant level, lubricant level, or steps to be taken for preventive maintenance, spindle performance graphs. So these are all part of the machine diagnostic software that we talked about. So several of our customers ask for a maintenance perspective where different parameters in the machine are displayed in a cockpit or in a dashboard with appropriate color coding and alerting system. And this data is continuously logged for traceability purposes. So examples of misuse of spindle, etc., can be figured out by monitoring the spindle load. If the spindle is being overloaded or if it is underperforming due to vibration, etc. So such things can be figured out by monitoring the spindle load and speed. If the customer is looking at a new part or a new machine, so we want to capture some performance indicators and then be able to compare them 6 months down the line. So profiling is a part of our software where we capture ideal profiles and then use them to compare with what is happening 6 months later or 1 year later. So we have a lot of use cases. And many of these systems are OE systems, OE monitoring systems, digital recipes like I talked about each of it, where the computer is shared between two machines on the shop floor, and we provide digital recipes instead of paper-based workflow. And we have energy monitoring solution. We have integration with ERP and other enterprise systems. So there are several use cases, and I will take you through some of those use cases in the next few slides. So one of the customer testimonials that we would like to share with you is from Beijing, where there are 200 plus machines. And having used our system for about 3 months on 10 machines, they recorded an improvement of 13 lakhs or a savings of 13 lakhs. And after 1 year on 22 machines, they recorded savings of 158 lakhs, which was an ROI of 200%. So this is one of the use cases. This customer is in Pune. We have one more use case where Super Corporation in Satara will manufacture cylinder liner, cylinder head system. So it took about 1 month to stabilize the OE monitoring system on one of the lines. And first week after stabilization, the average OE was around 58%. From there, it moved on to 60% in the next week and then 71% in the third week. So they have also identified what were the reasons where they were losing time. So the downtime went down from 392 hours in the first week after stabilization to 336 hours and then to 300 hours. So they saved a lot of money and they have identified areas for improvement. The tool-like monitoring is one key area that we have identified, and supervisor to operator communication is another area that we have identified for improvement. Triveni Turbines is a large turbine manufacturer in Bangalore, and they have about 21 machines with a capex of 50 crores. And after having used our system, OE and eShoplex, and energy monitoring systems, where OE increased from 35 to 56% after 1 year, over 1 year. So they have recorded an overall cost savings of 1.6 crores. The eShoplex solution has been implemented by deploying a tablet or a laptop at the machine. So initially, it was paper-based workflow, whether it's a job card or a drawing or a process sheet, program, etc. Now the entire workflow is changed by a planner in the background, and the operator uses only this console to get whatever information he wants. One more use case is PK Steels, where the objective was real-time OE visibility, work in progress status, and to know the aging of the part, casting to finished product. The PK casting manufactures valves for the oil and gas industry. So the process starts with the casting coming from the foundry into the shop floor, where we generate a QR code tag and tag it to the casting. And the casting starts moving in the shop floor. So we monitor OE of the system by integrating certain hardware with the machine. And also there is a PC deployed at each machine where inspection data, etc. is captured by the operator. The scanners are integrated with the PC, and this QR code tag is scanned as it moves from one process to another process. The final output of this system is an instantaneous snapshot of what is happening in the shop floor. So if you look at 12 machines, you exactly know what serial number is running at each machine. And then an aging report, where if you look at one casting, how many days has it taken to come out as a finished product? So in the last column, you observe that we are looking at 20 days, 19 days, 18 days, etc. Now, ideally, this number should be around 15 days. So after using the system for about 6 months, we were able to bring down this aging to 50. In NCR region, we have implemented this system on 65 machines. The objective was to get a real-time production status on the shop floor, understand losses, improve OE, they also had a challenge where there was a huge gap between the inventory recorded by SAP and what actually was happening on shop floor. So there was a gap between the inventory records of SAP and physical inventory on the shop floor. So we wanted to reduce that gap by syncing production count automatically after every job. And because there is a huge energy consumption in this manufacturing process, we wanted to monitor specific energy consumption on the physical side. A complex workflow has been implemented where data flows from SAP to our system and from our system to the machine, and again back from the machine to our system and then to the SAP. So at the machine, we have deployed a 7-inch HMI and a PLC to integrate with the machine. And all the 65 machines plus some 60 energy meters are networked, and all the data goes to a central server. The workflow is something like this. The operator comes to the machine, clicks a button to get the production plan from SAP in real time. So the request goes to our server forwards it to SAP. SAP gives back the data to our server, and the server, again our server, TPM track server, gives back the schedules to the machine. Now, operator selects a particular schedule, which is also called a plan. And once the SAP gives back the green signal that inventory is available for this plan, the operator proceeds to reserve the inventory and then starts production. So during production, we monitor production time, downtime, cycle time, load and load time, reasons, rejection, etc. And we give OE of the system in real time. We also monitor a lot of process parameters and energy. There are special workflows in place for notifying breakdowns and rework management. And then there is a concept of releasing the plan at the end of the schedule. So suppose he has reserved 5,000 numbers and he produced only 3,000 or 4,000. We can release the plan. When he releases the plan, the remaining inventory will be made available back to the tool. So these are some of the outputs from the system where you see different work centers, which parts are running on, which part is running on each work center, what is the schedule quantity, how much had to be completed at this point in time, and how much actually has been completed. What is the status of the machine, current status? So this is the shop handoff. Then we have a lot of dashboards which show efficiencies of each asset. There are several reports available in the system. This is an interesting dashboard where they analyze downtimes using the Pareto chart. And a similar thing is made especially for the press machines to understand breakdown phenomena, because there are many components that go into the press machine. So they have been very successful in reducing the downtimes by studying these dashboards and reports. And most of the actions now happen in real time instead of it being a breakdown kind of a scenario. So I talked about energy consumption. This dashboard gives to produce 2,500 parts, how much energy was consumed, which gives the specific energy consumption. It also tells you what is the minimum maximum voltages in each of the phases, and also gives a measure of the power factor. So in Belagavi, we have implemented a very sophisticated line monitoring solution. The parts that come in are cleaned, and then a 2D table is created for the part. So the gantry loads the part onto the machine, and when the gantry loads, there is a QR code scanner. The gantry scans the part, so the serial number of the part going into the line is available to the gantry PLC, and from there the part flows through CNC operations and then comes to a cleaning station. So at every stage, the serial number is validated to make sure that the previous operation has been completed successfully. Otherwise, it will not be allowed to go forward. So this is one validation, and at every stage, OE is monitored, process parameters are monitored, then special integration has been brought into effect by integrating with gantry PLC as well as equipment such as measuring equipment or a crack detection equipment or a washing machine, etc. So the workflow will involve providing the required information to the equipment. Like the inspection machine does not know which serial number is being inspected. So our system reads that information from the gantry PLC and provides it to the inspection machine. And the inspection parameters are tagged with the serial number and given back to our system. So then there is a quality gate after the inspection stage where the inspector can either reject or approve the part to take it to the next stage. So at that stage, laser marking is done and then forwarded to the MPI station for crack detection. So there are PC systems with which we integrate and take the process parameter data, whether there was any problem or not. And we also store some visuals like photographs and videos, etc. And then the part goes for final QA approval, where in the dashboard, all the process parameters and data that was collected in the previous stages is made available to the person, QA person, using which he will take the final decision whether it has run successfully through each stage. Then it goes to packing station. So these are some of the dashboards that are used for understanding cycle times, load unload times, down time. And then we have the final inspection dashboard. So this is for a particular serial number. And these are the different operations, operation 20, 30, 40, etc. And you see that some operations have happened successfully and some operations there is an X mark. So when you click on that X mark, you will know what is the problem, what problem had happened at that stage. And if the problem is minor and it is okay to be passed to the next stage, then the inspector would have passed it to the next stage. So we will see by serial number. This is a serial number dashboard. So on that particular day, these were the serial numbers that were manufactured, and for each serial number, if you click on that particular operation, you get the details about alarm information, whether any alarms were recorded when that operation was happening, what was the inspection data or the measurement, dimensional measurements that were made. So this kind of traceability we have brought into the system. So several dashboards and reports that are useful for the customer. Serial number wise production report, downtime report, operator efficiency report, tool change report, preventive maintenance transaction report, rejection rework report. So many reports and dashboards are available for the customer to understand where are the losses and how we can counter them. So one more use case is an axle manufacturing company where there are two lines and each station has got a PC associated with it. It is a wireless implementation. As the part comes into the line, it bears a laser marked QR code, so that will be scanned at the station one. And the as the part progresses through the station, each station, there are several checkpoints that have to be monitored at each station. Then it reaches what is known as the Atlas of metronome station, where we measure torque. The process parameters are captured along the line. And the similar flow happens in the second line, and it comes to a common section station, beyond which it goes to the packaging station once it is passed through the section station. So this is the typical operator screen. So here is a serial number, here is a part number. So in the first station, there will be a scanner. The operator will scan the part, and subsequently the same part moves through the line. So when he scans the part, It goes back to the server, checks for the standard time, brings the standard time back, and then enables the start button. The operator will start the process, and he is allowed to stop the process and record losses in between. And to help him with the checklist, which keeps coming here periodically through the production process, we display either a help file or a PDF document or a video using which we can do certain action. And he will also record whether it is okay or not okay, or yes or no, or some value he will enter here. So this is an important part of the process where the checklist is completed during manufacturing. So we give a serial number based production report, downtime report, quality report, traceability report, etc. So this is an example of the shop floor and-on where we show availability, performance, quality, and way of both plant and line. The line status dashboard displays exactly what is happening at that station, which serial number, which part number, what is the takt time, is there any downtime, all this information is displayed in real time in the line status dashboard. Coming to traceability, if you select a serial number, you can know the history, how it has been manufactured through different stations. Was there any problem? What was the cycle time? What was the downtime, etc. In the pre-dispatch inspection stage, against each serial number, a lot of parameters can be recorded. And if there were any problems encountered during production, those problems are recorded, like a downtime or a rejection, etc., against which they can understand the 5W1H process. So 5W1H process is what, when, where, who, which, and how. So it is like a YY analysis. They record root causes, etc., for further action. So this complete traceability system has been implemented and successfully running for the last 1 year. An example of a real-time feedback going into the CNC machine to improve the process or control the process is achieved in terms of automated tool wear offset corrections. So as you know, during production, the tool gets worn out, and periodically the operator is expected to adjust the tool by providing an offset value. So in a manual process, a lot of problems can happen where the operator, instead of giving it in the tool wear offset location, can by mistake provide it in the work offset location. Accidents happen, or he may not do it periodically. So to avoid these things, we have automated the process of measuring the tool wear, looking at the control parameters, and intelligently adjusting the offset to make sure that the process is under control. So these are called automated tool wear offset correction solutions. This is achieved by deploying certain hardware at the machine and then integrating the hardware to the machine. We also take inputs from the digital gauge into this hardware. The intelligence is built in the hardware to provide the required offset back to the CNC controller. So we provide run charts as outputs. We also provide X bar R charts. Everything is online and in real time. We also give an offset correction report. So a process engineer can actually go through this and study and look at what is happening. You also get a fair idea of which tool is performing better in your context. So such solutions are very powerful. I have come to the end of my presentation. If there are any questions, we can try to address them. Thank you.
Thank you, speakers, for the session. We have got questions. I'll just read out to them. So we have this first question from Mr. Manikandan KR. What is the solution approach for the calculating the OEE performance for the job production components for CNC machines?
So we look at three parameters, like availability, performance, and quality. So availability is a function of downtime. So we monitor downtime, and for monitoring downtime, we use the concept of a threshold. So let us say the customer is interested in measuring any downtime is more than 3 minutes. So the threshold is set at the machine, and if the machine stops for more than 3 minutes, we force the operator to provide a reason without which the next cycle will not be allowed to start. So that is one way of capturing downtimes and the reasons for the downtimes. The reasons are, we make it easy for the operator. Either it is codified as a list, or it can be a simple numerical code, like 100 means something, and 1 means something like that. And we capture these information in real time, and that gives us the availability of the machine. Next comes the performance of the process. So there are standard benchmarks that are established by the industrial engineering teams. So when a new part comes in, they do some studies and establish a benchmark that this part should take so much time. So that is our standard reference against which we measure the cycle time. So to measure the cycle time, we integrate a piece of hardware, or we leverage the controller APIs to look at the cycle times from the machine. And the gap between one part ending and the other next part starting is called the load unload time, during which the finished part is unloaded and the next part is loaded. This is the unloading time. So we take all these time and then arrive at the performance efficiency of the machine or the process. Next comes the quality. So quality can be decided in two ways. Either it is a manual measurement, in which case he has to enter if there is a rejection. The entry also we enable at the machine. Or if there is a digital gauge and the gauge is giving us the dimensional information, we can integrate it with our system and then decide whether it is a good part or a bad part. So now we have all the three pieces of information: availability, performance, and quality. The multiplication of APQ gives OE of the system. So the only thing now is to allow the user to define standard times, operating times, like what we call as planned operating time. Planned operating time will be defined in the software for each asset. So once we have all this information, we can decide the OE of the system.
The next question is from Raghu S. What are the pros and cons of cloud and local server based Industry 4.0 solution in a MSME perspective? Is your system cloud based?
We can deploy it in the cloud. Right now, at this point in time, we do not have a cloud of our own, which will probably come up in the next 4 or 5 months. But these solutions can be deployed in the cloud if the customer already has a cloud by himself. So that is one thing. Second is pros and cons is generally the customer segments that we operate in. For example, you take Bosch or somebody like that. They are very sensitive about their information going out of their network. In such cases, there is no option but to deploy an on-premise system. So most of our systems at this point in time are on-premise, but that doesn't preclude us from deploying systems in the cloud. We are comfortable doing that. The SME segment can leverage the power of cloud at this point in time. However, connectivity is still a question mark, because we have seen that in remote areas, even the mobile connectivity or the GSM connectivity is not good enough for continuous data acquisition. In which case, you may have to depend on a local on-premise server, which would primarily do the data collection and then forward the data to the cloud system as and when the connectivity is available.
There's a question from Mr. Kush Kumar. He's asking, is there any total number of installations of Amit product in India? So is there any number?
So as Mr. K Ramesh mentioned in his opening remarks, we have supplied about 20,000 licenses so far into the field, of which I would say at any point in time, 100 customers will be active. So at this point in time, we would have about 100 customers active, and we can take a benchmark of 50 machines per customer. So 5,000 machines will be active at any given point in time.
Okay. The next question is from Mr. Ajit Mutalik. He is asking, what is the time taken to deploy a OE solution in machining center?
If you are looking at, let us say 4 or 5 machines, then we can do it in a matter of 5 days. But if you are looking at a system where you have, let us say, 50 machines, and then the organization also has to be ready, it will take about 3 months for us to completely deploy and stabilize a size of 50 machines where the customer can start seeing some benefits.
We'll take it as the last question. So, Mr. Ginesh is asking if you could tell us something about your biggest installation till now, and can it work on DMG? Does your system work on DMG?
I got the last part. Can it work on DMG? What was the first part, Akriti?
The first part was if you could tell us something about your biggest installation till now. Biggest installation.
Yeah. So our biggest installation as a single project is about 75 nodes with about 60 energy meters and also diagnostic information coming from these machines. So it is like almost 180 machine node type of installation. It took us about 6 months to completely install and bring the system up and running. And this has been running successfully for about 2 years now. And we have a two-way integration between SAP and our system. And the integration is in the form of exchange of XML files between our system and SAP system. And we are looking at further expansion into other plants as well for this customer. And if I look at an extended implementation across many years, then Bosch is a good example where we have more than 300 nodes running. And we have many customer sites where there are 75 plus machines running across India. So most of these systems are focused on OE monitoring, energy monitoring, SPC data collection from digital gauges, and then inspection data collection from digital gauges and traceability type solutions.
Thank you, Mr. Madhusudan. There are a lot more questions coming. I will share the questions with you and the attendee list so you can go through and just answer them to them separately or individually because we are exceeding the time. So I would just like to wrap up the session for today. So thank you, Mr. Ramesh and Mr. Madhusudan for such an insightful session of today. And I would also like to thank our participants for making this session a success. We look forward to having your feedback, please. Thank you, everyone.
Thank you, CI. Thank you, all participants.
Yeah, thank you, CI, and thank you to all the participants.